Welcome to the VFD lesson. In this lesson, we will talk about how the VFD changes the speed of the motor. Here you can see a VFD and the motor. And here is the input of the drive, which normally is connected to the grid, the line. Then the VFD normally typically convert the AC voltage of the line to the DC. Then use the inverter to invert the DC back to AC. And actually, the input AC voltage and the frequency is fixed. And on the output side, the frequency and the amplitude of the voltage can be changed. And the output of the VFD wired to this three terminal of the motor. The motor can be either induction motor or synchronous motor. And by changing the frequency of the VFD output, the speed of the motor can be changed. This formula shows the speed of the induction motor or asynchronous motor. Here you can see N is the motor speed, and S is slip. Slip P is number of pole pairs, and not pole pairs. F is frequency of the motor terminal, which is the output of the VFD. So the slip is the ratio of slip ratio is normally very small, typically less than 5%. Actually, the formula for the slip is like N. Okay, this is the motor speed. This is the motor synchronous speed. So the actually S slip is the percentage of motor speed, the difference between motor speed and the synchronous speed, divided by the synchronous speed of the motor. So you can see by changing the frequency of motor, the speed can be, the motor rotational speed can be changed at the same time, which also linear. It means the speed and the frequency is in the linear function. So we have different ways to change the motor speed. Change the number of poles, but if you change the poles, you have you need to have more than one set of state winding in the motor. And also, when you change the pole, the speed will change with a step, and not continuously. For example, the 4-pole motor, the synchronous speed is 1500 RPM. And the rated speed is normally like for 1430, for example. And the 6 poles motor, 1000 RPM. And maybe the rated speed is 970 RPM, for example. So when you change the poles, the speed change from this to this. So during the change, there will be a big step of the speed change. The second one is change the slip. We can change the rotor resistor for the wounded load motor. And also we can change the state voltage, the amplitude of the motor voltage, not the frequency. You can also change the slip, then change the motor speed. So the best way is to change the frequency. So this is why we have the VFD, variable frequency drive. And here's the formula for the motor back EMF. This is back EMF. And this is the frequency of motor terminal. N and K is the is fixed as long as the motor is designed. For a certain motor, this is a constant. And the flux is this is a motor flux. And the difference between the motor terminal voltage and back EMF is stator voltage drop. So normally at high frequency, because the voltage drop is small compared with the EMF and the voltage, so the state voltage can be neglected. But at a low frequency, because of the voltage low, So the V voltage drop on the stator cannot be ignored. So normally, in most of the cases, the voltage is proportional to the F multiplied by flux. So when we change the speed by changing the frequency of the motor, we want to keep the flux to be almost constant, because the best way to keep the flux close to the design value of the motor. If you have the extra flux, the motor will be the core of the motor will be saturated. Then you get the extra heat. And if the flux lower than the rated, then you don't have enough torque on the motor output side. So the best way to keep the flux to the rated. So in order to keep the flux rated, you need to change the voltage proportional with the flux. That means, if you want the flux to be constant, then, V and F, V by F should be constant. That means when you change the frequency, you need to change the voltage at the same time. So here is the frequency, here's motor voltage. So when you do the speed adjustment, we want to keep the flux constant and change the voltage, terminal voltage linear with the frequency. So this is below the rated voltage and the rated frequency. If the speed, the frequency is higher than the rated, then you can increase the speed, increase the frequency, but the voltage cannot be increased because of the motor design. Otherwise, the motor insulation will be damaged because of the higher voltage. So that means, you increase the frequency, but the voltage keep the same in this area. So that means, the flux will be decreased with the frequency. So this area, because flux is constant, so the motor can have the maximum torque. So we can have constant torque. So in this area, because the flux decreased by the frequency, the maximum power output of the motor will be almost constant. So we call it constant power. So this area is the constant torque. This area is constant power. So as we told before, for stator motor, this is a relationship between, actually should be the frequency and the EMF with frequency. So in the low speed area, because of the stator voltage drop, in order to keep the motor flux constant, we need to compensate the voltage drop on the stator. So the actually motor terminal voltage will be in the red curve, not the green one. So this voltage, this is a voltage drop on the state for compensation. But on the high frequency and high voltage, because the portion of the voltage is very small, so can be neglected. So here is a mechanical characteristic of the motor, of the induction motor. Here's the torque. Here's the speed of the motor. This is the cyclic speed, which means slip is 0. Here, the motor is standstill. Slip is maximum, it's 1. So at the rated frequency, the curve is like this. When you reduce the frequency, the cyclic speed reduces accordingly, and the whole curve moves down. And on the low frequency, low voltage area, because of the voltage drop of states, the actual flux will be decreased. Actually cannot be kept constant. So the maximum torque will be decreased. Here is the maximum torque on the rated speed. On the low speed, the maximum torque will be decreased. So when we do the stator voltage compensation, then the maximum torque can be increased. Okay, this is for today's lesson. You can scan the code and get more information about the variable frequency drive.